हेलो बच्चों, हाउ आर यू? P100 physics, I am SDP sir. The remaining part of the numericals, okay, come on the point. Let us consider you have to give in, write the question, write in the form of the question. A wire of mass m and length L. There is a wire of mass m and length L. Length L. Folded in the form of semicircle. What is gravitational? What is gravitational potential at the center? Okay, what is given to you? This is a wire. This is a wire given to you. Mass of this wire is m and total length is L. This is folded in the form of the semicircle like this. This is folded in the form of the semicircle like this. You have to determine the value of the gravitational potential at this point, at the center. Suppose radius is r. Determine the answer. Wire. This is a wire. A, B. Here is also A, B, and it folded in the form of the semicircle. You have to determine the value of the gravitational potential at this point, at the center of the semicircle. Try to do this question. Okay, try to do. Taken a wire AB, folded in the form of the semicircle or the breadth, semicircle, in the form of the semicircle. You have to determine the value of the gravitational potential of this wire at the point C. Now check your answer. What will be the answer of this question? This is a very easy question. Directly by a single step you can solve this question. Since total length equal to L, total mass equal to m, so mass per unit length will be how much? M by L kg per meter. By this way, by the process of the integration, you solve this question also. Taken a small element, taking angle d theta. This is the element of the length dx and mass dm. Very easily by integration process can be solved. But without integration directly you can solve this question in the single step. How? Vg, you know that the Vg equal to minus Gm by R. You know Gm, m is the total mass, m upon R. R is the radius of this semicircle. Since length of this circumference of the semicircle equal to pi r equal to L, therefore R will be equal to L by pi. Very simple. In the single step the answer will be same. either solve by the integration process or by directly in the single step. Therefore, now putting the value of R, Vg will be equal to minus Gm by R. R means L by pi. L by pi. Then what will happen? Vg equal to minus pi Gm by L. This is the fantastic answer of the question. The fantastic answer of the question. Vg equal minus pi Gm by L. That is the answer. In a single step, you can solve this question very easily. Now, another way, let you want to solve by the process of the integration. Then, what will be the process? Take and देखो, ये है process first means trick. No? The very smart trick. This is a very smart trick. Okay. Now, by integration, second process of the question. Second process is the integration process. You know that dVg will be how much? Potential, gravitational potential developed by this, only this element will be how much? dVg equal to minus G dm upon R is the radius R. No problem. Put in the value of dm. dm will be how much? Dm will be how much? Dm is what is the dm? Dm is the mass of this element. Therefore, dm will be how much? Mass per unit length m by L into dx and ds will be how much? Dx will be r into d theta. Dm equal to mass per unit length into dx. Either you can write here dx. Now, dm will be how much? dm by L. ds means r into d theta. This is the value of the dm. Note the point. This is a very smart process. V is equal to so much, and this is the lengthy process. This is the first process of the trick. Smart trick. This is the smart trick. Directly you can solve it in a single step, that what is the value of the Vg. And this is the integration process. This is the some lengthy, but the answer will be same. Vg equal to minus pi Gm upon L. Okay. Write all the lines first. Now, since dm is here, putting the value of dm in this equation number 1, dVg equal to minus G dm equal to m by L r d theta. M by L r d theta upon what is here? Upon r. R and R become cancelled. Integrating this in the other line. Now dVg will be how much? Minus G m into d theta upon L. Okay, fantastic. Now write integrating this equation. 0 to Vg, and this is a d theta. It has to self-integrate. Theta equal to 0 to theta equal to pi. Okay, this will be the limit. Taken out, dVg will be how much? Means from 0 to pi. Vg, it will be Vg equal to minus Gm by L, that will be the common. Gm by L, that will come Gm by L. And d theta means theta. mind here, theta, d theta, integration of d theta, that will be theta, 0 to pi. What is the answer? Vg equal to minus gm by L into pi, because when put the value here theta equal to pi, that will pi minus 0, that is the 0. So therefore Vg will be how much? Minus pi g m by L. Fantastic answer. So by the both way answer will be same. This is the value of Vg. Limit theta barabar 0 here and theta equal to pi here. Okay, this is a fantastic way. But this is the lengthy process. Now you know the magical super trick. The first step, in a single step you can solve this question. Okay. Now, most important another question which has been asked in your examination also. This question also has been asked in your examination. Okay, in the Neet examination and IIT. Next question, most important question. Next, most important question. By the just a similar question. A wire of mass m and length L. You have to given a wire of mass m and a length here. It's folded in the form of the semicircle. It bent in the form of a semicircle. It bent in the form of a semicircle. What is gravitational intensity at the center. Okay, most important question. This is the wire. Mass of this wire is m, a, and we suppose this is the AB wire. Mass is m, length is L. It bent in the form of semicircle like this. This is the center. You have to determine the value of Ig here. What is Ig here? At the center. What will be the Ig, intensity of the gravitational field at the center of the semicircle? Try to solve this question. Close the video. Take 1 minute time. Check your answer. Okay, come on. Check your answer. Write the question. Come on to the point. What will be the answer here? To solve this question, you know that what is the intensity. First of all, what is the intensity of the gravitation? Ig will be how much? Ig will be how much? Ig equal to Fg upon m. You know that numerically Ig equal to Fg by m. Ig equal to how much? Fg by m. What is the numerical value of the intensity of gravitation? Force per unit mass. Determine the total force. Let us consider here at the center, let us consider a small mass m, and this mass is the capital M, this is the total mass. Total length is L, but taken another mass small m placed at the center. Small m placed at center. Small m placed at the center. Okay. Taken any element. This is the element. Taken a small part of the wire, that is called, in the integration process, always take an element, a small length. taken a small length, that is called dx always. This angle is d theta. This is the radius r, or here taken radius r. This is the radius r. Now mind, what is the per unit? What is the mass? What is the mass per unit length? Mass per unit length. Mass per unit length equal to m by L. Therefore, mass of dm is, this mass is the dm, mass of this element, no? From here to here, taken mass dm of the length dx, the dm equal to m by L into dx, or you can write dm equal to m by L into dx, dx equal to, you know, r d theta, r into d theta. This is the value of the dm. Theta, the limit of theta is from theta, from taken from here to here, vertical in taken from here to here, then here will be the theta will be pi by 2, and again from pi by 2 to here, this will be this section, this quadrant, angle of this quadrant will be up from pi by 2 to pi. Okay, same element you can consider here also. The same element in other side, you can consider same element also, and the same force is acting also here. This is the also dx. Okay, you can consider it. This angle also can taken d theta, but only from here you can determine your answer. Now come on the point. dm equal to so much according to the formula of the intensity. According to formula of the intensity, first of all, Ig equal to Fg by m. You know well that Ig equal to Fg by m. First of all, determine the value of Fg. Determine the value of Fg means the force acting on the small mass m. Force acting on the mass m. What is the force acting on this mass m? The force acting on this mass m. Fg will be how much? Fg will be how much? Fg will be this, between this and this. Fg will be how much? M dm g m dm g m1 m2 upon r square. This is the value of Fg. What is the force between this element and this mass? So this is the Fg. Since the force Fg is acting here, this is the Fg or df. It name is dfg. So this is also dfg. Then the component of this here will be df sin theta, and this will be df cos theta. This will be df cos theta. Here also df cos theta, and this is the df sin theta. Okay, df cos theta becomes cancel out. df cos will be cancelled out. Therefore, the net force will be how much acting in this direction? The net force acting in this direction, because df cos theta become cancelled. df cos theta equal to cancelled. Mind here. Understand this again. Dm, this is the mass dm. This is a small element of the wire. Consider a small element of the wire. This is the dx. Mass is dm. This angle is d theta. The component, let us consider the force is acting df. Then df cos theta will be here and df sin theta will be here. By the same way of this element, df cos theta for this, df cos theta will be here and df sin theta will be here. Therefore, along the y-axis, this is the y-axis, along the y-axis, df sin theta will be the sum. The net force will be df sin theta plus df sin theta means 2 df sin theta. But along the horizontal direction, component of this force, let us consider here is the df. So then df cos theta will be horizontal component and df sin theta will be a vertical component, because you know that in front of the angle there will be sine, on the base there will be cos. So df cos theta and df cos theta of this, df cos theta of this and df cos theta of this just in the opposite direction, and so that will be cancelled. Along the y-axis there is the df sin theta and df sin theta. The net force is acting how much? df sin theta. The net force is acting 2 df sin theta. Mind, the net force is acting. What is the net force? What is the net force? Net force equal to 2 df sin theta. This is the force acting on the particle M. On this particle, this is the net force acting toward the direction. What is the direction? Toward the j-axis. Toward j-axis. Okay, along the y-axis. This is the f. This is the f. Since this is df, therefore here also write the df. Here also write the df net. df net. df net. Okay. Integrating this from this side 0 to f net, and here this will be the integrated df, integration of 2 df sin theta and j. This is the vector. This shows the direction. Therefore df sin f net, this is the f net. F net will be how much? Taken 2 common, taken 2 out. df equal to how much? df equal to g m dm upon r square. Keep in mind this df. What is the df? So df equal to m dm by r square sin theta into j. Okay. Now integrating this from where to where? From 0 to pi by 2. From 0 to pi by 2. Okay. Note all the points. These are the very, very important points. Now put in the value of dm. For the final result, f net equal to how much? 2, take in common, g m upon r square, dm. But put in the value of the dm. Put in the value of dm. Put in the value of dm. dm is, mind here, m by l r d theta sin theta j. Okay, j. Okay. Now solving this. Note all the point. First of all, note all the point. What will be the direction of the net force acting on this particle? The force which acting on the small mass m, that will along the y-axis. In the x direction, means along the horizontal direction, there is no force because the cos component becomes cancelled out. Okay, fine. Come on, the next point. Solve this. Solve all these points. Solve this all these points. Okay, come on. F net equal to how much? F net equal to how much? F net equal to F net 2gm by r square. Mind here, this r becomes cancelled by this. The power will be single now. G 2g m and capital M and L both are constant. Therefore, 2gmm, mind 2gmm by RL by RL. Inside will be how much? Sin theta into d theta. Sin theta d theta. J is the direction. Theta is from 0 to pi by 2. From 0 to pi by 2. Okay. Therefore, F net is how much? What is the value of the F net? F net equal to 2G M by RL sin theta. Sin theta integration. Sin theta, that is the minus cos theta. Minus cos theta. Minus and minus, the sign of Fg is minus, that will be the plus. And what will happen? No. This is the only numerical value, and therefore what will happen? 2Gmm by RL sin theta into d theta. Sin theta into d theta. Sin theta into d theta means sin theta into d theta minus cos theta into 0 to pi by 2. 0 to pi by 2. Then what will happen? F net equal to 2Gmm by R into L will be how much? Okay, come on. R into L into minus cos, mind here. This minus sign taken out. Minus cos pi by 2 minus cos 0. Cos pi by 2 minus cos 0. Then for F net will be minus 2Gmm by R into L cos 90 0. This is the minus 1. Therefore F net will be minus minus plus. This will be the 2Gmm upon what? RL. But you know that the RL equal to, since you know that L equal to pi R, therefore R equal to L by pi. L by pi. Put in the value of L. Put in the value of R. R equal to L by pi. Keep in mind this. R equal to L by pi. Therefore L square and upon pi. Pi will be here 2 pi. 2 pi Gmm by L square. This is the fantastic answer. But you know, in the this Ig equal to minus Fg hota na. Ig will be how much? Ig equal to, always keep in mind, Ig equal to negative quantity. Ig is the minus. So minus, this minus will be appear here. This is the minus. Therefore the final answer of this question becomes, note all the point. Note all the important point. Most important question. Note all the point. Okay, this is a very fantastic proof. Okay, हो गया? Come on. Now come on, the next therefore the final answer of this question becomes F net equal to minus 2 pi Gmm upon L square. This is the fantastic answer of the F net. But you know, you have to determine the value of the Ig, and since Ig equal to minus Fg by M, so Ig becomes minus 2 pi Gmm upon L square into M become cancelled. The final answer of Ig becomes 2 pi Gm upon L square. What will be the direction? J. J. Okay, J means vector J. Vector J. This is the final answer. This is the final answer. Numerical value of this Ig intensity of the gravitational field becomes, there will no minus. Let remove this minus. This will be the numerical value 2 pi g m by L square into, this is the vector quantity, and minus, there is minus. No, keep in mind, since in your calculation there is no minus, therefore this quantity direction, this shows the direction, remove this minus. Okay, otherwise okay, now fantastic, this becomes plus. Already it has becomes plus, positive. Already it becomes 0 minus, this is the positive. Already this becomes positive. Keep in mind, always the negative sign, when it is in front of the scalar quantity, it shows the value is less than 0. But when the negative sign with any vector quantity, it shows the direction. Let here since Ig in the direction of the y, and let here put minus, then it will be minus j. Minus j, the direction of the Ig will be reverse, which is not possible. Therefore, Ig will be how much? 2 pi g m by L square into j. Okay, fine. Now, further, next question. Taken, next question most important. All questions are most important. P100 physics. Okay, P100 physics. Step by step. P100 physics. What is the physics? Okay, come on. Most important question. There it is given in the question, there are two masses M1 and M2. There are two masses. There are two masses M1 and M2, and at distance d apart, another mass एक तीसरा मास है, another mass m is placed at the midpoint, another third mass is placed at the midpoint of these two. What velocity, what is minimum velocity required to escape m? Means by diagram, suppose this is a mass m2, here is another mass m1, another third mass is placed at the midpoint, means this is the d by 2, and the total distance from here to here is d. What velocity given to this? Determine this velocity v so that it escape. To escape this, what will be the minimum value of the v? Okay, to escape this mass small m, to escape this mass small mass m, what is the minimum required velocity? What is the minimum required velocity given to this? Try to do. Try to do. Okay, come on, check your answer. Check your answer. According to law of the conservation of energy, you know well that the total energy at the initial position will be equal to the total energy at the final position. since at final position, E final will be 0, that will be potential energy plus kinetic energy. Therefore, E final equal to 0 plus 0 barabar 0. How it is so? Because what is the minimum velocity? In your question, it is asking that what is the minimum velocity required to give to this mass small m so that it can escape. This is your basic question. And therefore, since you are given this minimum velocity, and therefore at the final whole given kinetic energy will be expenses in the way, and at the final position there will be no energy, remaining energy of the kinetic energy which is given to this small m, that will be expenses. Okay. Therefore, what will happen at the final? The total kinetic energy will be 0, and at infinity you know well that the potential energy always, gravitational potential energy at final position is always 0, and therefore 0 0, that is the 0. What is the total energy initial? Therefore, since here will be u1, here will be u2, and the kinetic energy also given, this is the mass and velocity given to v, and therefore the total initial energy will be how much? Total energy initial means EI will be how much? U1 plus U2 plus kinetic energy, means a set will be here between this potential energy of gravitational potential energy will be between this and this, also between this and this. Okay, because you have to determine the value of this small m. Then this small m will energy due to this, and this small also has energy u2 due to this, and there will be kinetic energy also because velocity is given, and therefore EI will be how much? EI will be how much? U1 d by 2, this is the distance, you know, that is the minus GM1 GM1m, U1 will be how much? GM1m upon d by 2 minus U2 will be how much? Minus GM2m upon d by 2 plus kinetic energy half mv square. What will happen? EI equal to 2 will be in upside, minus 2 into this, no, not there will not 2 will be here, therefore minus 2 GM1 m upon d minus 2 GM2. Okay, come on. Again, EI will be how much? Minus G minus 2 GM1m upon d minus 2 GM2m upon d. Okay, plus half mv square plus half mv square. This is the initial total energy. You can take in common. EI will be how much? 2m by d minus 2m by d. 2m by d can be taken common. Then what will be here left? m1 plus m2. m1 plus m2 plus what is here? Half mv square. Write all the lines. And okay, draw this diagram. Come on the point. Next, Now solve this. Since apply the law of the conservation of energy, this is the final energy and this is the initial energy, both will be equal. Applying the law of the conservation of energy, E I equal to E final. E final equal to so much, and therefore you can write half mv square will be goes toward the after this equal, then this will becomes half m v square equal to minus sign and minus sign from both sides will be cancelled. 2m by d in the bracket 1m1 plus m2 can be written by the law of the conservation of energy, can be written like this. M and m cancel out. This 2 will be cross multiply. V will be how much? 4 in the bracket m1 plus m2 upon d under root. No problem. And this is the fantastic answer. This is the fantastic answer of the question. This is the fantastic of the answer of the question. कोई भी दो मास है m1 और m2, उनके बीच की दूरी d है, उनके बीच की दूरी d है, ठीक बीच में मिडल पॉइंट पर एक छोटा मास रखा गया इस मालयम, कितना वेलोसिटी उसको दे दें कि वह एस्केप कर जाए. वेरी सिंपल. व्हाट इज द आंसर ऑफ दिस क्वेश्चन? v इक्वल टू अंडर रूट 4 m1 m2 अपॉन d. yes, there should be a g also. There should be g also. Yes, there should be g also. 2g also taken common. So half m square 2g. Here will be 4g. This is the g. Universal gravitational constant will be also there. This is the fantastic answer. Okay, mind. Fine. This is the final answer of the question. This is the final answer of the question. Okay. Come on the next question. All questions are the most and most step by step P100 physics. Okay, come on. Note all the point. Note all the point. Come on the next question. Most important question. Determine value of acceleration due to gravity. Determine the value of acceleration due to gravity determine the value of acceleration due to gravity at the height okay. Again write the okay. Question will be like this. Determine height at which, this is the question has been asked in your examination. Determine the height at which acceleration. Note the question first. Determine the height at which acceleration due to gravity becomes equal to the acceleration due to gravity at depth d equal to re inside. Okay, so much the question. This is a very fantastic question. Understand this question. Determine height at which. You have to determine the height from the surface of the ground. You have to determine the height from the surface of the earth. At what height the acceleration due to gravity becomes just equal to the acceleration due to gravity at a depth d, where d equal to re. This is a very fantastic question. Solve this. Solve it. Try to solve. Try to solve this question. Okay, check your answer. Check your answer. Since you have studied the variation of the acceleration due to gravity, there are three factors. There are three more important factors on which the gravity acceleration due to gravity depend. Number one, gravity acceleration due to gravity depends on the acceleration due to gravity depends on the number first, shape of the earth. Number second, with the height, altitude. Number third, with the depth, and also it depends on the rotation, rotational motion of the earth along its axis. Okay, therefore, since you know that variation with the depth when we go inside the earth, then how acceleration due to gravity varies. The equation of this GD with depth, that the equation of this is G1 minus D upon R, you know well. Therefore, what is the value GD equal to, since it is given that D equal to R, therefore G1 minus D upon 1 minus D upon R, not, since 1 minute, D equal to not 1, because some other values are given perhaps. D equal to R by 2. Okay, not R. Correct the question. D equal to RE by 2. Okay. Correct the question. D equal to RE by 2, because let D equal to RE, then G will be 0. There will be no question. Because D equal to, at a D equal to RE, this is the D equal to RE. RE by RE, that is 1. 1 minus 1, that will be 0. That is the center. D equal to R equal to, that point will be the center. And at the center of the earth, you know, Ig will be 0, and acceleration due to gravity also becomes 0. So since that point is D equal to RE by 2, correct in the question. Now come on the point, 1 minus D equal to RE by 2 d equal to Re by 2, d equal to Re by 2, Re by 2, and this is Re given, Re becomes cancelled. G d will be how much? G 1 minus 1 by 2. 1 minus 1 by 2. What is happen? G d will be how much? G by 2. G by 2. This is the G d equal to G by 2. Fantastic. This is the value of the G. But you have to determine the value. The height above the ground, the height above the surface of the earth, at which G becomes so much. G becomes so much because in your question it is given that GH will be equal to GD. Equal to GD. Keep in mind, anywhere, this is a very smart trick. This is a very smart trick. This very smart trick, what? Let you have to determine the value of H. In your question, it is asking that at what height the value of G will be so much. At what height value of acceleration due to gravity becomes so much. Since let GH, it is given in your question that at what height H, the value of G becomes G upon N, where G is the value on the surface of the earth. Any such type of the question you can solve in the single step by a single line. How? Let us consider this is the question, and you have to determine. This is a very, very smart trick. Note the point, write with the red pen. GH equal to G upon N. Let it is given anywhere, and you have to solve. You have to determine the height. Then that height will be how much? This is a very smart trick. H equal to root n minus 1. Root n minus 1 into Re. Root n minus 1 into Re. This is a very fantastic technique. This is a very, very fantastic technique. Keep in mind. This is a very twisted question and very good question. So H equal to root n minus 1 into Re. Fantastic. Now n is how much? Here, keep mind. H equal to how much? Okay. GD equal to GH equal to your GH equal to just equal to this will be equal because GH equal to GD means the value of acceleration due to gravity. Which value is the value of the acceleration due to gravity at a depth Re by 2. At a depth d equal to Re by 2. The same value will be above the height. How much? At what height the value will be same? Since you know that the acceleration due to gravity, let at height h, acceleration due to gravity at height h means gh equal to g by n. Let gh equal to g by n. N is the integer, n is the any number, or the fraction may be also there, n. Then a smart trick with this, h equal to, directly you can determine the value, h equal to by under in the bracket root n minus 1. Root n minus 1. Keep in mind, 1 is not under the root. Root is only here on the n. Root n minus 1. In your question, since it is given both are same, this and this both are the same, therefore g h equal to g upon 2. Comparing this equation, from this equation, n equal to 2, n equal to 2, putting the value here of the n. Therefore, what is the value? H equal to, what is the final answer? H equal to root n, root 2 minus 1 into Re. What is the final answer? H equal to, since you know root 2 equal to 1.414, 1.414 minus 1 into Re, 1, 0. H equal to becomes 0.414 into Re. This is the answer. Therefore, the answer of this question becomes Answer of this question becomes H equal to 0.414 into RE means 6400 kilometer. Multiply this H equal to 4 from these two 0. It will be 41.4 into 64. Can be written? Can be written? Multiply this 1.4 into 64. Solve this. One. Okay. Six, 9, 4, 26, 1 plus decimal will be here. 2649 means 2650. You can say that is approximately. That will be 2649.6 kilometer. This is the final answer. Approximately you can say it has been asked in your IIT examination, and therefore the final answer was given there 2500 250 kilometer. This was the correct answer. Means approximately 249.6 kilometer. This is the fantastic answer. Okay. तो कितना आसान है सब कुछ ना. हाँ. P100 physics. Again, the next question. Note all the point. Note all the point. Okay, fantastic. Next question. The similar question. Try to solve the question and give the answer. At what height from ground, from surface of earth, at what height from surface of earth acceleration due to gravity becomes 1/4. How much at what height the acceleration due to gravity becomes 1/4 of the acceleration due to gravity on the earth's surface? Try to solve. This is a very fantastic question. Just I described it. Okay, check the answer. What will be the answer? Check the answer. Since you know, let anywhere g equal to g by 4, gh equal to g by n is given. I just described the very smart trick. What? H will be root n minus 1 into r. This is a very smart trick. This is a very smart technique, smart trick. Now mind, gh equal to g by n. In your question it is given that gh equal to g by 4. Therefore it shows that n equal to 4. According to this, h will be how much? Root 4 minus 1 into re. What will happen? h equal to 3 re. Root 4, that is 2. Root 4, that is 2. 2 minus 1 2 minus 1, that is the RE. H equal to RE means at what height? 6400 kilometer. That is answer. The final answer of this question becomes H equal to RE. H equal to RE, and the numerical value RE barabar R equal to 6400 kilometer. Therefore, the final answer will be 6400 kilometer. Okay, come on the next question. Most important. All the questions are most important. All the questions are most important. Next question. Escape velocity on a planet is 50 kilometer per hour, 50 kilometer per second. Mass of planet is 4 m and radius is r. Mass is the 4 m, and radius is r. Okay, mass is m and radius is r. What will be escape velocity? What will be escape velocity where on a planet which mass equal to 4 m and radius is 3r. Try to solve. Most important. I have described this type of the question. This type of question already I have described. Okay, just in the previous video. Try to solve this question. Okay, come on, check your answer. Pause the video and try to solve in the 1 minute. This is the most. All questions are very important. All questions are the very important questions. Come on the point. What will be the answer of this question? What will be the answer? Okay, you know Vp upon Ve equal to how much? That Vp directly proportional to m, inversely proportional to r, and you can write Mp upon Me into, means one is taken, this is taken just like, let us consider this is the taken, or you can say, okay, no problem. That first is taken as the, second is taken as the planet, and first is considered as Earth. Then you can write Vp by Ve equal to Mp upon Me into Re upon Rp. Or you can say R1, R2 can be written, M1 and M2 can be written, and here will be half root. Solve this. This Ve is given 50. Okay, first of all, escape velocity of the planet, escape velocity on a planet is 50. Let us consider that planet is Earth or any other planet, because on the Earth the value of the escape velocity is 11.2 km per second. Therefore, you can consider another planet, any planet. Then Vp will be how much? Ve 50 km per second. Mp mass of the planet 4m, 4m upon mass of this me, that is the m into re. Radius becomes r. Let radius becomes r is equal to r. Then rp becomes, rp is the rp of that planet is 3r. This is the 3r. This is the fantastic way of the solving this question. M and M becomes cancelled, R becomes cancelled, and you will get Vp equal to 50 into, here is 1 by 2, here is 1 by 2, 50 into 2 upon root 3. That is the 100, okay, 50 into 2, that is the 100 upon root 3. 50 upon 100 upon root 3. This is the half, means under root means 2, this will be 2, and 50 into 2, that is the 50 into 2, that will be the 100, and upon root 3. This is the so much kilometer per second will be the answer. Fantastic answer. What is given in your question? Escape velocity on any planet. On any planet, escape velocity is 50 kilometer per second. The mass of the planet is m. Mass of the planet is m, and radius is r. It is given in your question. In the question, it is asking that what will be the escape velocity on any other planet which has mass 4m, which has mass 4m, means mass of the other planet at which you have to determine the value of the acceleration due to gravity. No, escape velocity, that is mass of that planet is 4m, and the radius is the 3r. Very simple. Since you know this is the most important technique, most important formula, Vp by V equal to mp upon me into Re by Rp into 1 by 2. Also this formula, this question has been solved in the form of the acceleration, in the form of the density. Replace this 4 by 3 pi r cube, 4 by 3 pi r cube into rho. Again this will be also replaced by 4 by 3 pi r cube rho, means when the ratio of the density is given. When ratio of density is given, then okay, come on, the next question. Next, what is the next question? Determine the change. Most important question. Determine the change in the potential energy, greatest potential energy when a mass m displaced from Earth's surface to the height h equal to Ra. Here may be h equal to 2 Ra, or Re by 2 also, or Re, or 3 Re. There will be this value of the h may be variable. H equal to Re has been asked in your exam. H equal to Re, h equal to Re by 2, h equal to 2 Re, h equal to 3 Re. Yes, maybe. Try to solve this question. Most important question. Consider this is the just out question. So much important. This is the most important. Solve this. Okay, come on. Check your answer. Check your answers. Pause the video. Take 1 minute time. Solve the question. Then check it. And here, let us consider this is the surface of Earth. This is the surface of Earth. Center Mass is ME, radius is RA. Another mass is here. Suppose here is a mass M, and it displaced from this point to another point here. The height is H. The height is H. Mass is M. Replaced from here to here. What is the change in the gravitational potential energy? The work will be done. In this question, the work will be done because you are going to shifting the mass of this mass against the gravity. Therefore, the work will be done. Then the change in the what will be the change in the gravitational potential energy? Keep in mind, delta U will be equal to the work done, W. Delta change in the gravitational potential energy will be just equal to the work done. Let in your question asking what is the work done in the process, or either asking the question what is the change in the potential energy, the answer of the both will be same. Delta U will be just equal to the work done, W. Very, very smart and fantastic technique. This is the very, very important formula. Keep in mind always, delta U equal to W equal to M, mass of the body which is shifting, M G, small g, RE square 1 by R1 minus 1 by R2. This is the very fantastic trick. This is a very, very fantastic technique. Keep in mind. Underline this line. Underline this by the red pen. Okay, delta U equal to W equal to mgre square 1 by R1 minus 1 by R2, whereas R1 is the distance of the initial distance from the center of the earth. R1 equal to initial distance of M from center, and R2 equal to final distance from center. R1 is the initial distance from the center and R2 is the final distance from the center. Very fantastic. In your question, what is given? In your question, initial distance from the center is equal to radius. Therefore, R1, it is clear from the question, from this figure, R1 equal to RA, and R2 will be how much? Since H equal to RA, this is the RA. Since this is the RA and this is the 1 RA, then RA plus RA equal to 2 RA, means R2 equal to RA plus RA, R2 equal to 2 RA. Fantastic. Now putting the value of R1 and R2 in this equation. Put the value of R1 and R2 in this equation and get the answer. How? Come on. Putting the value in this, delta U will be how much? mg RE square in the bracket of 1 upon RE minus 1 upon 2 RE, because R2 equal to 2 RE, R2 equal to 2 RE, R1 equal to RE, and solving this, delta U will be how much? mg RE square multiplied in numerator and denominator by 2. This is the 2 upon 2 RE minus 1 upon 2 RE. What is here? Delta U will be how much? mg RE square 2 minus 1, that is the 1 upon 2 RE, 1 upon 2 RE, this power becomes cancelled. Delta U will be mg RE by 2. This is the fantastic answer. This will be equal to the W also. This is the answer. mg RE by 2. This is the work done. W equal to mg re by 2. Most important, this is equal to either delta u equal to mg re by 2. Fantastic. Both answer will be same. Both answer will be same. Now another question, just based on this formula, solve yourself now. Most important, solve yourself. Write the question. What will be work done? What will be work done to displace a mass m from Earth's surface to the height re by 4? Try to do. Fantastic. Solve this question. Solve this. No, check your answer. Check your answer. Okay, check your answer. Since h equal to re by 4, you know that when a body is shifting from Earth's surface to any height, let any body shifted from Earth's surface to any height, then what is the work done? What is the formula? There is a fantastic formula. I have described just work done W, that will be just equal to also the change in the potential energy, and that is given H. W will be how much? Mg Re square. Mg Re square in the bracket 1 by R1 minus 1 by R2. Keep in mind this always. Keep in mind this always. Now in this question, what is happening here? R1 equal to R1, that is body is on the surface. R1 equal to Re, and R2 will be how much? R2 equal to Re plus height H. Therefore R2 equal to Re plus Re by 4. It is given H equal to Re by 4. So R2 will be 4Re plus 5Re. 5Re by 4. Okay. Now put in the value. W will be how much? Mg Re square. All question has been asked in your examination. Most important. 1 by R1, 1 by Re minus 1 by R2, 1 by R2. R2 is 5Re by 4. 5Re by 4. 4 will be becomes numerator. What is happening here? W equal to Mg Re square. 5Re multiplied by 5. Multiplied by 5. 5 by 5 Re minus 4 by 5 Re. What is here? W will be how much? Mg Re square. Here will be 5 minus 1, 5 minus 4, 1. 1 by 5 Re. 1 by 5 Re. Re cancel. Then W will be W equal to Mg Re by 5. Okay. This is the answer. Mg Re by 5. Mg Re by 5. Okay, no doubt. Okay, come on. This is the final answer. MGRE by 5. Okay, come on. Another question. Another question. Very fantastic question is given. Very fantastic question is given. Taking that Earth revolve around Sun in circular orbit of the radius. Okay. The question is, let us consider time period of Earth revolution around Sun. Let us consider time period of Earth revolution around Sun is 1 year and distance is 15 into 10 to power 10. The value is given 15 power 10 meter. 10 power 10 meter. Then what will be? Then what will be time period? Then what will be time period of the planet which revolves around Sun in orbit of radius 450 into 10 to the power 10 meters. 450 into 10 power 10 meters. That radius becomes 4 into 50, 4 into 15 to 10 power 10 meters. Then what will be the time period? My dear, it is given. Let us consider. It is given a question that let us consider the time period of the Earth is 1 year. That is the 1 year. Of course, that will be the 1 year actually. In the actual practice, that is the 1 year. And consider let us consider time period of Earth revolution around the Sun is 1 year. Okay. And the distance is 15 to 10 power 10 meter. Then what will be the time period of the Earth and other planet? Then what will be the time period of another planet? Any other planet, time period of any other planet will be what? Let us consider the radius of that planet is 450 to 10 power 10 meter. 450 into 10 power 10 meter. 450 into 10 power 10 meter means 450 into 10 to power 10 meter. Determine the answer. Very fantastic. Most important. Solve this question. Solve this very fast. Check your answer now. Okay, come on. Now check your answer. Since R1 and R2 are given, since R1 and R2 are given, since R1 is given 15 into 10 to power 10 meter and R2 is given 450 into 10 power 10 meter. T1 equal to 1 year. You have to determine T2. Very fantastic. You know what you know? T2. You know that T square equal to R cube. You know this is the Kepler's third law. This is the Kepler's third law. Therefore, T2 upon T1 square of this it will be how much? R2 cube upon R1 cube can be written. T square at T proportional to R cube, Kepler's third law. Therefore, T2 square upon T1 square can be written R2 cube upon R1 cube. Or T2 square equal to T1 square into R2 upon R1 can be written very easily, no problem. Putting the values, T2 square equal to 1 year, 1 year, 1 is 1 square, R2 450 into 10 power 10 upon R1 15 into 10 power 10, 15 into 10 power 10, 15 into 10 power 10 mind into 3. Becomes cancel. Therefore, T2 square will be how much? T2 square will be how much? 540. Mind here. 450 was given. No problem. No problem. This R2 was 450. 450. It is not 450, but 540 given in the question. 540. Take it 540. In the question, in your real question, the value of R2 is the 540. 540 to the power 10. 540 into 10 power 10 upon R1. R1 was 15 into 10 power 10. And this is the cube. 10 to the power 10 cancel. And what will be here? 3 into 5, 15. And 18, 180 can be written here. 180 can be written here. And therefore, this will be how much? 5, 3, 36. 36 power 3. Fantastic. Fantastic. Again, what will happen? Since this is mind here now, T square equal to will be how much? 36 power 3 by 2. 1 by 2 means T will be how much? So much years. 3 by 2. 1 by 2 taken root 6 into 3. T will be 6 into 6 into 6. 36 into 6. 216. 216 years. This is the very, very fantastic answer. This is the answer. So, use of the Kepler's law in your standard, in Neet and IIT. Yes, this question has been asked in your examination just in the Neet 2022. Also, a question was based on this. Okay, come on the next important question. Most important. Another question. it is given the ratio of density of two planets is 2:3. Let radius of both are same and time period of a satellite around first is yes, the value is given for 36 hour. Then what will time period of same satellite about other planet? Okay, most important, it is given a question that the ratio of the density of two planets, there are two planets, any two planets, different planets, there are any different planets, but having same radius. There are two planets having same radius, but the density ratio is 2:3. Both planet has their satellite, identical satellite in the same radius. Means the radius around the both satellite is same. Time period of the satellite around the first planet is given, that is the 36 hours. Then what will be time period of the same satellite about the second planet? Solve it first. Most important, solve this. Okay, come on, check your answer. Check your answer. Since you know that t equal to 2 pi under root, okay, no, time period of satellite, remember any formula of the time period which is in the form of the density? Have you know any formula? Okay, I have described this formula, t equal to under root 3 pi upon rho g. This is a very fantastic formula, keep in mind. Okay, so t equal to under root 3 pi upon rho g. This is the most important formula. T, let us consider there are two planets, TA and TB. Time period of A upon time period of B, 3 pi and 3 pi becomes cancelled already. G will be in the same. G will be cancelled by G. 3 pi will also cancel. Means TA by TB will be how much? That will be equal to rho B upon inversely proportional. Rho B upon rho A. Yes, fantastic. This is a very simple question. Directly you can solve this. Therefore, TB will be how much? You have to determine the value of the TB. Therefore, TB will be how much? T inversely proportional to rho. TA upon TB equal to rho B upon rho A. TB, you have to determine the TB. So, TB will be equal to टी ए, देखिए टी बी इक्वल टू टी ए क्रॉस मल्टीप्लाई टी ए अंडर रूट रो ए अपॉन रो बी, टी बी इक्वल टू टी ए 36 आवर गिवन अंडर रूट रो ए अपॉन रो बी, रो ए 2:3, 2:3. The answer will be T B equal to 36 under root 2 upon 3. This is the answer. Fantastic. This is the answer. Okay. Come on the next question. Come on the next question. The length of the secant pendulum is, it is given in the question, length of secant pendulum is 1 meter. Anywhere length of the secant pendulum is given 1 meter, and acceleration due to gravity, acceleration due to gravity is 9.8 meter per second square. What will be length of same pendulum where acceleration due to gravity, where acceleration due to gravity is, solve this. Length of the secant pendulum, mind. What do you mean by the secant pendulum? Any pendulum, any simple pendulum which time period is 2 seconds, that is called secant pendulum. So secant pendulum is what? Any simple pendulum which has time period 2 seconds, that is the secant pendulum. Length of the secant pendulum is 1 meter. This is a very simple question. Okay, solve fast. Solve very fast. Check your answer. Now check the answer. Okay, come on point. Since you know that T equal to 2 pi under dl by g, this is the simple formula. When T becomes 2 seconds, this is called secant pendulum. Therefore, secant pendulum, this is 2 equal to 2 pi under root L is 1 upon g given 9.8. Another equation that has also secant pendulum, but 2 pi again here, but L is, you have to determine the value of L, and here it is given 4.9. Equation number first and equation number second. Since left hand is 2 here also and 2 here also, left hand are same, therefore the right hand will be also same. Then what will happen? 2 pi under root 1 upon 9.8 equal to 2 pi under root L upon 4.9 can be written. Now 2 pi becomes cancelled, squaring both sides. 1 upon 9.8 equal to, what will be happen? L upon 4.9 can be written. Therefore, what is happen? 4 and this is the 2. 1 by 2 equal to L by 1. Therefore, L equal to 1 by 2, that is the 0.5 meter. That is the answer. The answer is the required length equal to 0.5 meter. The required length is the 0.5 meter. Fantastic. Okay. P100 physics. Come on the point. Next question. Next question. Okay. The remaining portion. Now, there are many questions. There are many important questions still now. So the remaining part of the questions will be discussed in the next episode. This was the episode number. Gravitation episode number 7. This was the gravitation episode number 7, and the next remaining questions will be discussed in the next episode, gravitation part 8. That will be most important question, just like the questions which will become the most important questions. What will be the velocity at the final position? Let a body is throwing with the speed n times of the escape velocity. Just let us consider a body is thrown with the speed 2ve, twice of the escape velocity from the Earth's surface. Then what will be its final kinetic energy and what will be its final velocity? Such type of the questions, and there are many questions which are given in your NCERT books. There are some important questions in your book, NCERT books also. That questions we also taken. Okay, the remaining part will be discussed in the next episode. Okay.